Hi, I'm Chris D'Souza. Today I'm going to talk about object-oriented programming, specifically in comparison with procedural style of programming. So the agenda is, first of all, to introduce the data structure of an object type, and then that is in UML notation, that's its class structure for an object in UML notation, and then write a Python code for such a class, and then compare it with the procedural style, with its equivalent procedural style, and then conclude regarding the advantages of object-oriented style. First of all, what is object-oriented? When you talk about object-oriented style, the focus is on identifying objects in the real world rather than on processes. For example, if you are asked to find the average expenses for a day, we do not think in terms of functions such as getAverage. Rather, we perceive the world as being made of an object in the form of, say, a daily expense calculator. And that calculator may then contain a behavior to calculate the average. So the focus is on identifying these things rather than the processes. The focus is not on the processes. The focus is on identifying things. So the focus is not on this. Whereas in a procedural style, the focus is on identifying the processes. So let's get into this a little further. First of all, we may think in UML notation, we represent a thing such as this using a class. So the class will have a name, and the thing may have a set of attributes and a set of behavior. So the attributes represents the properties of the class that need to be changed. For example, the values, the daily expenses may need to change, or you may need to compute something based on the daily expenses, in our case to get the average, and we may need this functionality that computes, so that's called the behavior. So we have three rectangles in UML notation, UML class diagram specifically. We have three rectangles, wherein the first rectangle represents the name of the class, the second rectangle contains all the attributes, which contains the properties of the class, and the third rectangle contains all the behavior. So this is an abstract form of representing the thing that belongs to the real world. So it's called a model of the real world. So it simply is used to identify what's expected, what are the properties, and what's the behavior of the class, but no finer details are provided in the class diagram. So correspondingly, if you have to write this code in Python, we will need a class, and we write the name of the class there, and then we will have attributes, and we'll have some function. Specifically, a class will have a special method, a special functionality, and in this case we no longer use the word function, we use the word method to initialize the attribute, and such a method in Python is init, but the general term for such a method is called the constructor. So we use this is the constructor. Constructor. So the utility of a constructor is to initialize the attribute of the class. So in this case, we've got two behaviors apart from the constructor. One is called the set days expense, that is to initialize the attribute. In this case, we use self.days expense to indicate that this is the same attribute that's there. And we've got getAverage, which is to get the average. Remember, this was an abstract notation, and this is the concrete implementation of this class. So this is the class only highlights the abstract details, whereas the actual implementation will contain the full details of that class. So given a list, for example, if you have a list which represents the daily expense, so first thing you could do is pass this to the class, and that is to instantiate the class. So we use this statement, the name of the class, and if the constructor expects a parameter, in this case it expects two parameters, but the first parameter by default is the object's that is created itself, that is set by default. So that one's not passed explicitly by the programmer. And the second parameter is a day's expense, which is this that is passed. So this I need to pass it so that I can initialize the attribute. And once the attribute is initialized, then that is available to all the functions in that class, all the methods in that class. For example, I do not need to pass the day's expense because that is available to get average by default. So once that's there, I can then so the constructor, when this is invoked, this creates an object, and this object in my case is referenced by the variable expcalc. So this is the data type of dxpcalc is daily expense calculator, and it represents an object of the type daily expense calculator. So once I have an object, then I can invoke any method, that is any behavior from it, by using the dot operator and along with the method name. So in this case, I'm getting the average. So this is a simple implementation of a daily expense calculator. So let's see how this compares with the procedural, with its equivalent procedural style. So this is the procedural style of programming without using object-oriented programming. So to get the average, we would think of a method, we would think of a function called getAverage, and you would pass this as a parameter as before, and then it would get the total sum, and it will find the total number of items, and it'll give me the average, and that average is written there. There's nothing special about this. So this looks neat, and in this case actually it looks much more smaller than the corresponding object-oriented code. But let's see what happens if the code needs to change. So let's assume this code works fine for a few years, but then there's a new requirement, and new requirements are very common in the real world. So let's assume the new requirement is to also get a weekly expense calculator, not just a daily expense calculator. But we know a weekly expense calculator is actually can be thought of as being made of a set of daily expense calculators. So let's first ignore that for a moment, but let's assume how we would have maintained this using the procedural style, which is here. So first of all, because we now need the average for not just for daily expense, but also for weekly expense, you'd probably be thinking that this function getAverage is a bit confusing. So you may probably think that it's better to rename that to get a day's average and create similarly another function called getWeek'sAverage, so that you can explicitly differentiate between day's expense and week's expense. So you then have, for example, a lists of such code for which each value here, each set here represents a day's expense, another day's expense, another day's expense, etc. So you may think of these as a list of lists, and that may be passed to it, and then you may use a for loop and etc. So let's not be bothered about the actual code there, but you may somehow get so in the process, when you get each value here, you may then invoke the daily function, and that demo function will give me the average for that day, and you may add it up to get for the whole week. So that is the overall logic that you'd apply. So correspondingly, if you have to do the change in the object-oriented style, you would not make any change to the daily expense calculator. Rather, you may think of the need for another calculator, call it weekly expense calculator. The weekly expense calculator details, the final details are exactly similar, except that this time we have an attribute called week expenses, and we have another function, another method called getAverage. And this one will give me the weekly average, and this one represents the weekly expense. So as before, we have something very similar being passed as an argument to this calculator class. So here we are creating an object of weekly expense calculator. So when this gets called, it will call the constructor. The constructor's utility is to initialize the attribute. So it'll invoke this function set week expenses so that we can initialize week's expenses attribute. So once that's done, I can then get a reference to the object. In this case, wexcalc is the reference to the weekly expense calculator, and then using that I can call get average to get the thing. So if you look at this, you will know that this one, as before, will use the daily expense calculator to create an object of the day's expense, and then use the daily expense calculator get average to get it. So this is something very similar to what we have done here, but the main difference between the two approaches is that here in this object-oriented style, we have not made any changes to the code that was existing previously. In other words, something that was executing perfectly 100% every time. No change was made. In other words, if at all there is an error in this code, we are scoping it to only the changes to the error to be made into this particular part only. Whereas in the procedural style, you would see the changes have been made not just to this part that required a change, but we also made a change to this because you had to scope. So that typically is a problem with the procedural style. So in procedural style, when the changes are required, we intend to change other parts of the code, which may result in breaking code that was executing properly in the previous case. So the summary of this is, in conclusion, I can say procedural style requires changes to existing code when maintenance needs to be done. Whereas, and that means procedural style is expensive from maintenance point of view. Thank you very much.